Good morning, everyone. Today we will see mathematical analysis by substitution method. There's an algorithm that gives solution to the problem. When we do analyze the algorithm, we are deriving the recurrence relations for the given algorithm. It shows the performance of algorithm or how it works. That is called recurrence equation. It's a mathematical equation. The performance of algorithm represented in the form of recurrence relations. By solving recurrence relation, we can find the time complexity of given algorithm. The time complexity T of n can be determined from the recurrence relations by applying many methods. One of the method is called substitution method. Today we will see how it works for solving recurrence relations. Recurrence relations of time. The equation represented in the form of time. T represents time complexity of given algorithm or time taken by the algorithm to produce the result. Where n represents number of inputs or input size. So the mathematical equation recurrence relation represented in the form of T and n. Here the terms, it includes many terms, T of n by b, T of n minus 1 with respect to n. The factor depends on the input size n. It is used to analyze the algorithm to find the time complexity. Here it shows the performance of proposed solution. When input size increases, what will be the impact of execution time? That shows the order of growth that can be derived from the recurrence relations. For example, T of n is equal to T of n minus 1 plus T of n minus 2. T is running time, n is input size. Running time or execution time of particular algorithm on input size n is T of n minus 1 plus T of n minus 2. So now this is one relation. We are going to solve the relation by applying substitution method to find the time complexity. What are the steps to analyze recurrence equation and find the time complexity? First, there's an algorithm that provides solution to the given problem. From the algorithm, we are going to write the recurrence relation of the proposed algorithm, and we are going to solve the recurrence relations by applying substitution method. There are so many methods available: Morse's theorem, iterative approach, and substitution method. Today we will see substitution method. So solve the recurrence equation using substitution method and represent the recurrence relation using asymptotic notations. So after finding the relation, solving the recurrence relation, we can apply the asymptotic notations to find the time complexity of given algorithm. And substitution method for solving recurrence equation or recurrence relation. This substitution method, always called as guess and verify method. It is mainly guess and verify method is mainly used for analyzing the divide and conquer algorithm, and it is a mathematical technique used to solve recurrence relations, especially in algorithm analysis. It gives solution, and we are proving whether the solution is correct or not by using induction method. Substitution is especially useful when Marshall theorem does not apply. Here it always work on both upper bound and lower bound. So big O notation is used to represent upper bound and big omega is used to represent lower bound. This method is useful for finding the upper bound. That is the maximum time taken by the algorithm to produce the result. That is the substitution method. Next, we will see what's the approach, what's the basic idea of substitution method. Guess the solution and provide it using mathematical induction. It is used for getting a guess of the closed form, especially for divide and conquer algorithm. Guess the algorithm to the recurrence equation. That is a guess the upper bound, the maximum time complexity of the proposed algorithm, and using mathematical induction, we can prove the guess results are correct or not by induction method. So induction first we are proving for the smaller value of n, then we can keep on increasing the value of n, so we can prove for n also. Substitute the guess into the recurrence relation to verify and adjust it. And one more example for substitution method. So for finding n factorial, for a positive integer n, the factorial of n is denoted by n factorial. So n factorial is equal to n into n minus 1 into n minus 2 up to 1 with the base case 0 factorial. 0 factorial is the termination statement when the algorithm will be terminated. That is 0 factorial is 1. The recurrence relations can be written as T of n is equal to T of n minus 1 plus 1. Here, what is T of n? Time taken by the factorial algorithm to produce the factorial of n value. This execution time by the algorithm is called T of n. That is equal to T of n minus 1 plus 1. What is T of n minus 1? Time complexity for n minus 1 input. So 5 factorial, 4 factorial, 3 factorial, 2 factorial. Like that, n value will be decreased by 1. And for each and every value, there's one multiplication. For example, 5 into 4, one multiplication. 4 into 3, another multiplication. 3 into 2, another multiplication. So plus 1 is for every iteration, there is one multiplication. That is called plus 1. So what's the base case? If n value becomes a 0, time complexity for n0 is 1. That is 1 multiplication. So the reference relation can be written as T of n is equal to T of n minus 1 plus 1. Next, we are going to expand it. So what is T of n minus 1? If n is input, n minus 1 plus 1. If n minus 1 is input, T of n minus 2 plus 1. So already we have plus 1 that can be added. Again, what is T of n minus 2? T of n minus 2 equal to T of n minus 3 plus 1. That can be substituted in the equations. So substitute the value of n minus 1 in n minus 2 and find the value of T of n minus 2 and substitute the value in the equation. Like that, it will go till it reach T of 0. N becomes 0. So in that case, T of 0 into n into 1. So for that value, this summation value is 1 plus 1 plus n. So n ones. And so the final value will be T of 0 value will be 1. So 1 plus n, n. So the solution of T of n is n. That can be determined by substituting the value of one factor or one term, T of n minus 1 value in terms of T of n minus 2, T of n minus 2 value in terms of T of n minus 3. So that can be used to find the T of n. T of n is equal to order of n. That is order of n, which is linear growth. What is linear growth? When the number of input n is increased, the change of or growth of time, execution time is linear. And we will see the algorithm function factorial of n. If n is equal to 1, 0 return 1. That is 0 factorial is 1. This is the base case when the algorithm will be terminated. Else, return n into factorial of n minus 1. That is initially n value is 5 means 5 into factorial of 5 minus 1, 4. So 5 into, again the function call. Again that will be calculated. Again 5 into 4 into factorial of n minus 1. So like that it will be repeated till n value becomes 0. So this one method for solving recurrence relation, substitution method. Substitute the value of one term in the same equation to get the final result for the given recurrence relations. And one more example, this is for divide and conquer approach. Here we can guess the value that can be proved by induction method. So T of n is equal to 2T of n by 2 plus n. What is 2T? The given problem is divided into two subproblems with n by 2 inputs. So T of n by 2 plus T of n by 2. Two subproblem with input size n by 2. When we match these two solution subproblems, algorithm performs maximum n number of basic operations. So plus n is for each merging operation. When we match the solution of two subproblem, it performs maximum of n basic operations. So that is the explanation about recurrence relation. T of n is equal to 2T of n by 2 plus n. So here we are going to guess the value. Our guess is mainly the divide and conquer approach. All divide and conquer approach depends on the time complexity n log n. So that can be proved by substitution method and induction method. So first we are taking the minimum value of n. That's the initial case. It's a base case. If n is equal to 1, t of 1 is c, where c is constant. Assume that t of k equal to c into k for all values of k, which is greater than or equal to n. That analysis based on input size n. If n increases, what will be the change in the time complexity t of n? Next, induction step, substitute t of n by 2 into the recurrence relations. So, what is t of n by 2 equal to c into c of n by 2 log n by 2. Substitute these value t of n by 2 in t of n. So, we are getting cn log n by 2 plus n. Again, that can be solved by log of n by 2 is equal to log of n minus log of 2. That is log of a by b equal to log a minus log b. That formula can be applied. So when we expand this, c into n log n minus c into n log 2 base 2. So we know log 2 base 2 value is 1. That really can be substituted in the recurrence relations. So the value is c equal c into n into log n minus cn plus n. So now take the value t of n is equal to c into n log n plus n into 1 minus c. M is common term, so we can take outside. So 1 minus c is constant. So what will be the order of growth? We are taking the maximum term, that is term with maximum value of n. That is the upper bound value. That is order of growth. So T of n is order of n log n. So in this equation, we have two terms in n. So n one, another one is n log n, which is more n log n value is greater than n. So take n log n value. So that is the time complexity of given recurrence relations. So the general step of substitution method is recurrence relation can be expanded by substituting some terms in the form of n and solve the recurrence equation and find the result. Another one will be apply substitute method for divine contour approach. Get the value and apply the induction method. So prove the result or guess with some additional information. That is called substitution method. Thank you.